Thank you. I would like to advertise our upcoming work on open-moduli infinite distance limits in 6D F-theory. The study of this problem can be motivated in two ways. First, from a Swampland point of view, one would like to understand the relation of these limits with the distance conjecture. And from a purely F-theoretic point of view, one would like to know the fate of codimension 1 and higher non-minimal singularities. Next slide, please. And I mean here infinite distance non-minimal singularities, because the codimension 2 finite distance non-minimal singularities have already been understood as SCFTs, as we have already heard in many excellent talks in this conference. Out of the 6D F-theory basis, one can argue that the P1 favored case is a natural starting point for such a detailed analysis. And indeed, we perform this analysis consisting of two parts. First, an involved algebra geometric analysis of which limits are possible. And second, an interpretation of them in terms of the Swampland conjectures and the dual heterotic theory whenever this one is available. The resulting models are a chain of surfaces intersecting at curves, and we explicitly analyze the types of surfaces that one can have, how they are constructed, and the structure of the discriminant, finding that they are the compactification limits in a dual sense. Thank you.
Hi, today I'd like to talk about some work in progress with Fabio, Federico, and Sakura, where we're analyzing symmetry structures from a brane perspective. So the starting point of this is the idea that the topological generators of generalized symmetries can be viewed as branes wrapped on boundary cycles in string theory setups. And the goal of our work is to try and understand what brane physics tools we can use to probe these symmetry structures. And for the purpose of this Gong show, I've just highlighted three kind of broad brush ideas we're looking at. So the first one is the action of these symmetry generators on charged objects, and we can do that by putting branes through one another. The second is looking at brane intersection. So in that way, we can study how topological generators of one codimension can act on one of a different codimension. And lastly, we can look at the fusion rules of these topological generators by considering stacks of branes and looking at the world volume terms on that stack. Yeah, thank you. Yeah.
Hi, thanks for the invitation for the Gong show. My name is Ruiwen. I'm a PhD student from this institute in the capital city of Estonia, Tallinn. My supervisor is this guy, and I collaborate with them in these two papers. So I'm a phenomenologist. I'm mostly studying the gut theories. So a gut theory is a good thing because we can use less parameters to explain more parameters. I think the central, from my personal perspective, the central question that we ask in phenomenology is the naturalness problem. So if we can use fewer parameters to explain more parameters, it's a good thing. So in gut theories, if I some unified coupling, it's natural because when you turn on the unified theories become tricky. So if you do some traditional framework, like as I did, I unify the fermions in 3 generations in one.
So this is like work in progress, whose primary motivation is like a recent field theory result that I find very interesting. And I don't know how to click the slides. Okay, cool. Not cool. Okay, so like, right, a field theory result that I find very interesting. And the statement is that in 40 U1 Maxwell theory and also like massive QED, there exists like a non-invertible time reversal symmetry at rational theta angles, rather than just say like theta 0 or pi. So like a natural question to ask then is whether there's an analogous statement for other field theories, like gauge theories, with possibly non-abelian gauge groups such as SUM, like variants of F with different global structures, but like same gauge algebra. An equally interesting question to ask is whether there's graphicalization like Stringy to address this, like we realized that one can use the fact that RL fields live in twisted K theory, and this actually allows us to explicitly construct a family of defects that rationalize realize these rational time reversal defects. Thank you.
See which button it is first. That button. Good. Okay. All right. First, a very quick thank you to the organizers for organizing this whole thing and giving me a chance to tell you about some upcoming work with collaborators that you just saw, but this is a different project, I promise. We're talking about condensate defects from tachyon condensation. So the idea that we've seen several times now, which I'll just say and hope that this works out, is that we can have QFTs that have these non-invertible symmetries. There we go. We can find operators that I've denoted as D, that when we try and fuse them with its naive like inverse, there isn't really an inverse. It gets this thing out the other side that we're going to call C for a condensate defect. We also know that we can realize these operators from string theory by just taking some kind of DP brane, reducing it down, and looking at its action on our operators in the QFT. What we don't exactly know is if we can get directly to C from something in string theory. Now, the idea is that we can take just a brane, an anti-brane, fuse it together, and use something like tachyon condensation to get a lower dimensional brane, then reduce that down. But, well, I guess not but. The hope is basically to complete this square. We know the bottom one, we know the left one, we know the top one exists. The hope is that we can get all the way down to this corner from that corner, and then use this to figure out some kind of condensate defects and other non-Lagrangian theories in general. Thank you.
Thanks.
There it is. Oh, okay. The slide switching is. Oh, all right.
N=3 theories that are not N=4 theories were discovered in 2015 using S-folds by Enoch, Garcia, and Diego Regalado. These theories are mysterious and non-Lagrangian, but we can predict their higher form symmetry. Sorry, this is the final. We can predict their higher form symmetries with holography. So the field theory is formidable, but the holographic dual description isn't. In the dual description, we have Branes from type 2B string theory, and we can study how they link and have that data, and we can use that data to predict the higher form symmetries of the field theories. And we do precisely this in a paper that was released last week, where we have new predictions about the one-form symmetries of these theories, and we also reproduce results known about the N=4 theories. Thank you.
Okay, yeah. So how do I hold this? All right, good.
Hang of this. Okay. Yeah, how do I move it? How do I move it? Oh, wait, there's a delay. All right, I'm just gonna go with this. All right. So hi, my name is Ethan. I'm from Penn. And today I'm going to tell you a little bit about what McKelly already touched on with this project to appear. So the goal of the project is to study some orbifold quotients of some common G2 cones with the idea that these are Brine-Solomon cones, which precisely don't have quantum corrections to their geometries. So over here, I illustrated a geometry for a particular ZK quotient of the cone over CP3. And we see that the cones literally represent some sort of codimension 4 singularities with a AD type singularity, AD -1. And the red and blue lines represent some 5D SCFTs. Now, on the field theory side, what this looks like is two 5D SCFTs with some sort of SUD flavor symmetry coupled with position-dependent coupling, and the 4D physics is localized at the boundary there. Thank you.
Hi, I'm Xingyang. I'm a student from NYU and now visiting in UPenn. So I'm gonna talk about some non-invertible symmetries of 2D gauge theories from 2B string theory. So the basic idea is followed from all recent works on string theory realization of these generalized global symmetries. And I will set my stage on 2B string theory on Calabi Orbifold probed by D1 branes. So this is one example. You have a 2D 0,2 theory on the D1 brane volume. And you can derive the symmetry TFT of this kind of gauge theories by reducing the 2B topological term on the asymptotic boundary of the Calabi Orbifold. And one term, very interestingly, is just the coupling between 3-1 form fields. So these are background gauge fields of 3-0 form symmetries. So based on the construction of Kaidi, Omori, and Zhang in the 40 QFT, if you're gauging two of these three global symmetries, the leftover one will become non-invertible, and the generalized global symmetry operator corresponding to the D branes, which reconstruct the transition of the local operator through the line non-invertible line defect, which like in 2D CFT and in 2D gauge theories, but now it's like at the Hamilton transition of the branes. Thank you.
Okay, can I give you 5 seconds? Sure.
Hello, everyone. Let me try to follow up Leung's talk by presenting a nice formulation of our result in 7D frozen gauge theories. So remember, we're looking at 7D frozen singularities, which are M theory on AD singularities with fractional holonomy of order D on the boundary. For example, SO2n plus 8 with 1/2 flux would give rise to SPN. So as Leung mentioned, we use this MF theory frozen duality by Tachikawa to derive a local freezing map of M theory in terms of this PQ7 branes and string junctions. So a very nice formulation of our result is the following. So for a type G singularity, an order D frozen flux would project the entire G root system onto the orthogonal complement of the span of a set of frozen simple root, where a frozen simple root is a simple root whose thinking comark is not a multiple of D. So we kill the bad roots. And it works for all cases, but let's focus on the D-type case. So by looking at the extended linking diagram of a D-type Lie algebra, we notice that we should kill the 4 nodes on the corner with thinking label, with thinking comark 1. So then the surviving roots are spanned by these betas, which precisely organize themselves into an SPN affine simple root system. So let me conclude my talk by mentioning that this rule is reminiscent of the freezing rules that are proposed in these literatures in the global context. Thank you very much. I'm sorry for this struggle time.
So thanks to all the